Okay, so this is the third component of our Monday lecture series on the accessory organs of digestion associated with the small intestine. We've talked about the pancreas, talked about the liver and the gallbladder and how they're connected with supplying bile to the duodenum. Okay, so let's talk a little bit about the bile. Okay, it is produced, as you might remember, by the hepatocytes, the liver cells, and the liver cells will secrete them into little canals in between the cells called canaliculi, and they drain into the branches of the bile duct, and the bile duct is part of that triad, the hepatic triad or portal triad. That drains into the hepatic duct, and it joins with the cystic duct to create the common bile duct, which eventually will supply bile to the duodenum. Now, the constituents of bile. Well, the first one isn't shocking. It is water. The second one is bile salts, and that's the only real functional part of bile. This will help. It's like a detergent. It helps break up big droplets of fat that are in the small intestine, and in doing so, it increases the area that enzymes can act on, the surface area. Okay. It also has bile pigments. The only thing that they're known for is they give you the color of your feces. So that's a waste product. Next. Okay, let's talk about the flow of the bile now. We already talked about how it's made and what it's made of. Now we talk about the flow. The flow initially, we should talk about the hepatic duct, because that's the duct that drains the liver, and that's what initially is the route of the bile that's just been produced by the hepatocytes. So next you have the cystic duct. Now the cystic duct is this duct over here, and that is from the gallbladder. So when the hepatic duct and the cystic duct come together, they call that the common bile duct, and that's this one right here. And that flows into, actually right through the head of the pancreas, and it combines with the very end of the pancreatic duct. Remember, this is the pancreatic duct right here, and this is the major branch of it. And they come together at the ampulla of Vater. So the bile as well as the pancreatic secretions are stored there in a little reservoir, waiting for secretion stimulation to open that sphincter of Oddi, so that the contents will be drained into the small intestine. Next. Okay, now we've learned how the bile is made, what it's made of, and the route it takes to the ampulla of Vater just before it's released into the small intestine to help with digestion. Now, the production is continuous. The hepatocytes never stop making bile, so there's a bit of a backup. And the sphincter of Oddi is generally closed unless it's stimulated. The default of the sphincter of Oddi is it's always closed. Now, since it's always closed and there's always bile being produced by the hepatocytes, there's a backup in that ductal system so that the gallbladder will fill because of the overflow. Okay. And part of the intestinal phase of the meal response is secretion of a hormone called CCK, or cholecystokinin. And what that does is it does everything you need for digestion in the duodenum. It inhibits the gastric secretions, so the pyloric sphincter closes, and gastric secretions stop within the gastric phase of digestion. It also stimulates, the CCK stimulates pancreatic secretions. So pancreatic, the acini cells will be activated, and they will start secreting, because they secrete on demand. And it also stimulates the contraction of the gallbladder to push that reservoir of bile out, and it relaxes the sphincter of Oddi, all of which are necessary for digestion in the intestinal area. Next. Okay, so now we've talked about how bile is produced, what it's made of, and the ductal system, as well as the gallbladder that stores it. Now, this last slide is what happens when this system goes awry. The production of gallstones is a common pathology, and worth noting right here. As it says in the first line, they're most commonly cholesterol, but it can be other components. So let's talk about gallstones in a generic way. They're caused by the function of the gallbladder, which involves concentrating bile. Now, bile, when it's produced by the hepatocytes, has quite a bit of water in it. In the gallbladder, that's pulled out. If it's pulled out too much, you don't have just a goo, you have a solid stone. And this can be caused by either genetics or dietary indiscretions. It is a problem because these stones will sometimes go down into the cystic duct or into the common bile duct and disrupt flow. And then you'll have that colicky pain that occurs when you have pressure behind a stone, and then it'll cause quite a bit of pain, and then it'll be relieved a bit when the pressure is enough for the bile or any kind of liquid to go around that stone, whether it's here or in the urinary tract. We'll talk about that a little bit later. Now, the biggest problem is if this stone lodges all the way down past where the common bile duct and the pancreatic duct merge. If that's the case, you'll not only have a backup in pressure and bile pressure in the bile system, common bile duct, but you also will have a backup in the pancreatic duct, and that is very serious. As you can imagine, if you have a backup in the pancreatic duct of pancreatic digestive enzymes, you're going to auto-digest the pancreas. And this is a very serious situation and one of the most common causes of pancreatitis. Very, very painful and dangerous situation. So, having said all of that, we're all done with this, with Monday's lecture series, and we'll see you Wednesday. Thank you.